Okay, now it's recording. So can someone like be in charge of this?
I'll be in charge of it. I'm right here.
I'll be able to.
I got you guys.
No, Alex, you need to focus. You really need to raise your grade.
I want to do today. First off, real quick.
I got it.
There are some papers over there in the period 3 pockets. You pass them back to Abby or Ian. Next, there was this worksheet called Integral as Net Change. I think I passed it out. So I wasn't quite sure what I was going to do with this.
That was not me.
So can you take it out? You definitely have it in your presentation.
That was not me.
Hey guys, can we have a very short period? Can we like stay focused? Your entire binder? You should like probably go with that.
I have
Some cause for concern. Alright, so you guys have this worksheet? Okay, this is actually something that's, you might think this is actually just kind of obvious. This is a worksheet I normally do it like the day after the fundamental theorem of calculus. But we just kind of kept not running out of time and whatever. So, I'm pretty sure I gave everybody one of these already. So we can use
Wait,
compile
this
now.
one?
So, yeah. Alright, so here's what it says. Basically, basically there's this thing called the net change theorem, which is actually sort of the whole point of doing integration. And the whole point of doing integration is that if you take the integral from a to b of the rate at which some quantity changes, then what you get is f of b minus f of a, the net change. Alright, so this is something that we've really been talking about for months, but now that we know the fundamental theorem of calculus, we should be able to apply this in all kinds of different situations. So let's just we can do this whole worksheet in like 5 minutes. If V of t, so let's read number 1 together. If V of t is the volume of water in gallons in a reservoir at a certain time, t, where t is measured in hours, then its derivative is the rate of change.
Ian, come look at this.
Can somebody else pass this out? Because I need to focus on it.
Okay, yeah, sure. Just drop it, whatever.
Divya, can you come look at this?
Okay, so then V prime is the rate of change at which, it's the rate of change of the volume of water. So it's the rate at which the volume is changing. In other words, if V prime of t is positive, what does that mean? What does it mean if the rate of change of the volume of the water is positive in words? More water is, there's more water in the reservoir. The amount of water in the reservoir is increasing. In other words, we can interpret that as water is flowing into the reservoir, or at least more is flowing in than is flowing out, right? And if on the other hand, the rate V prime of t, if that's negative, then what does that mean?
It's getting
The amount of water in the reservoir is decreasing. In other words, there's more flowing out than flowing in. This is just kind of common sense, like reading comprehension. Okay, so what does the integral from t1 to t2 of v prime of t dt, what does that represent in words? What does that mean?
the
Volume of water. The rate.
function. Does
Not
that
the rate.
change?
V prime of t is the rate.
It's how much water
The
there
rate
is
of
at
the
a
rate.
certain point.
Whoa.
The net change of the
Yes.
volume.
I'm shooting in the dark.
Yes, this is by the fundamental theorem of calculus, this is v of t2 minus v of t1. In other words, it is the net change in the volume of the water. It is the net change in the volume of the water from T1 to T2. And by the way, why is this true? It's actually not really even the fundamental theorem of calculus that's relevant here. What's relevant is just this basic kind of analysis, which is, suppose we draw a graph of this is V prime, and this is time, and here's time T1, and here's time T2. And I have some graph, and the volume maybe looks like this or whatever, right? Then what I'm doing when I find the area under this curve is I'm drawing a bunch of little rectangles, and each one of these rectangles represents something. This first rectangle represents, well, the height of the rectangle is like the rate at which the volume is changing. And then this little time interval is the amount of time that's gone by. So the area of that rectangle, if the volume is changing at this rate for this amount of time, then what is the meaning of the area of that rectangle?
is like the amount you add.
That would be the amount of water added over that short time interval, right? And then I go to the next rectangle. The height of that rectangle is the volume, is the rate at which the volume is changing, and the width of the rectangle is the amount of time that's elapsed. So if you take the rate at which the volume is changing times a little bit of time that goes by, then the area of that second rectangle is the amount of volume that was added during that little time interval. And so when you take the integral from T1 to T2, you get the net change in the amount of water. Is everyone cool with this? Okay, let's do 5 more. Number 2, an object moves along a straight line so that its position is given by S of t. And then the velocity is S prime of t. So what does the integral from T1 to T2 of the velocity, what does that represent?
Oh, I know.
Gabby?
S of T2 minus S of T1.
Yes, in other words, in words?
The net change of the position.
The net change in position. Net change in position from T1 to T2. Also known as the displacement. Right? In that case, we have a special word for it. Okay, am I going too fast? We're pretty much cool, right?
Wait, can
So
you, what? I don't, what?
Let's go on to the next one.
No, I don't understand.
Number 3. So everyone read number 3 and think about it for a second.
Wow.
Yeah.
Change in growth.
T1 and T2.
Or the amount.
Yeah.
Net change.
Okay, so if W prime represents the rate at which a child is growing for a particular time, so let's think of it as like age, right? So if T is the age of the child in years, and W prime of T represents the rate at which the child is growing at a given time, then what does the integral from 5 to 10 of W prime T dt, what does that represent in words?
Net change in growth. Years.
Yes, it is how much weight the kid gains from age 5 to age 10, right? Which should be positive. If your child is losing weight from age 5 to 10,
That's a big problem.
it's a big problem.
They're probably in the back though.
Okay, number 4.
No, what if
oil
it's like
leaks,
an obese 5-year-old and then
can
like
you
a
read? Can you do
super-
number 4? Right now. Good. So R of T this time represents the rate at which oil leaks from a tank. Rate.
Good afternoon. Pardon this interruption, please. I'm looking for Arnold Mung.
Yeah.
I need Arnold to report to 346 to see Ms. Kraft. This is an AP issue. He'll return to class shortly.
Okay.
Thank you.
So lucky.
Okay, so this is the rate at which oil leaks from a tank in gallons per minute. So then, what is the integral from 0 to 120 of that rate in words?
Amount of oil spill.
It's the total amount of oil leaked.
In gallons.
Total amount of oil leaked in gallons over the first 2 hours. Is everyone pretty much straight with
Wait,
this?
what was it? I'm not.
Like,
Total-
can you say the answer to number 3 again? What's the difference between this and number 3?
No,
This one gave you units, so it's easier to do.
The rate. This has units too. The rate of growth of a child in pounds per year.
Both the
This
net.
is going to be the amount of weight gained. Of weight
So really,
gained
it's just the whole fraction thing.
in pounds.
Wait, because like the derivative is
The amount of
Like-
weight gained in pounds from age
What are
5
you
to age
talking
10.
to?
Mr. Rosalie.
What's up? Did I just cut you off?
Yeah, like.
Okay, what are you saying?
So like, the derivative is basically like the fraction of stuff over time, and then the stuff
Correct.
is the function. So like, the
Yes.
stuff is the stuff you're.
Wait, Alex, you
Yes.
realize I
Yeah.
can't,
That's like a little, I got you.
can't see it.
Okay, number 5. Are you guys, Mountain Chalk, are you doing, no offense, but are you doing this alright?
I don't know. I didn't know.
I can't video.
What are you
This is like gonna be one of the worst videos because we can't see anything.
No, it's fine. Just don't zoom
Like, we can't see the 4.
Yeah, because you pushed it like 5. Why
Well, no, even when it's back, you
Someone
can't
else
see
did
it.
What's wrong? Everything's fine. Oh, just because of Angel's head?
Yeah, because of that, you can't see it even when it was far back.
Okay, it'll be fine. They'll get over it. It's not that big of a deal. Alright, so, number 5. Can everyone do number 5 really quick?
Oh wait, I have a question about 4.
Yes, Gabby,
So
question
is
about
that
4.
basically saying the net change in gallons from 0 to 120 minutes?
Yes.
Okay.
Oh. Wait, but these are different. Because this one's the derivative of a rate, and this one's just a rate.
But it really doesn't matter because I'm asking you to explain your answer in words,
Can you
right?
look at mine?
So,
Yep.
so what I've
But
said
with
is
they,
that
different things.
Same here.
In the child.
But you don't
These are all totally separate, different problems.
Oh wait, but this is just, it doesn't.
Okay, I think I did it, but like, I don't know where the 100 goes.
Yeah, that's really
100
important.
Plus.
Okay, yeah, so here's the thing. So here's what we have. We have a population of honeybees, and it increases at a rate of N of T bees per week. So N of T represents what in words?
The rate of change of the bees.
Yeah, this is the
Bees
rate.
over time.
This is the rate of change of the bee population in
Bees per week.
in bees per week. Okay, so given that that's true, what is the integral from 0 to 15 of N of T dt? What does that represent?
How many bees were added to?
Oh,
Yes.
after 15 weeks.
This is going to be a number after all, right? And this, actually, wait a second. Write an expression about an interval of the number of honeybees after 15 weeks. Oh yeah. So this represents the change in the number of bees
Are these questions?
between. Can you stop talking for a second? The change in the number of bees between week 0 and week 15. Okay, so is that the answer to the problem? No, right? We want a function which will we want an expression which represents the number of bees. This represents the change in the bees. So therefore, how many bees actually are there after 15 weeks?
100 plus that.
That plus 100. Yeah, so there are 100, this is what it should be saying in your brain. There are 100 bees at week 0 plus the integral from 0 to 15 of the rate at which the number of bees changes represents the number of bees after 15 weeks. Is everyone okay with this? I feel like we're okay, yes.
Did you put the 100 inside?
You cannot put the 100 inside. It doesn't go inside. 100 has nothing to do with the rate at which the bees are changing. 100 is simply how many bees I start with. This is how many bees I start with, and this represents, if you've been following numbers 1 through 4, this represents the number of new bees that I got or lost between these two time periods. Okay, I feel like this is okay, because we've kind of been talking about this like throughout the whole unit indirectly. Yes. Ian Thompson, do you have a question?
I was just wondering if these type of questions are going to be on the test.
Yeah, sure. I mean, this underlies our entire. Well, okay, actually, good
This
transition.
is what the integral is.
Yeah, this is just what the integral is. It's what it means, right? All the stuff we've been doing before is just like math, but now we're doing actual using that math to answer actual questions. Did I hand out to this class? I can't remember if I did or not. A worksheet called AP Practice Problems on Net Change, where you have to use your calculator.
Yeah.
I might have just like told everybody to grab one. Does this look familiar? If you have
Yes.
seen this, can you grab it? Yes. Okay. Zach has it, so that must mean you all have it.
Can you do it?
We weren't supposed to.
What?
We aren't supposed to do that.
I'm gonna run out though. If you have one, can you please find it? Okay, so this is a problem which I passed out last week, which also only takes like 10 minutes. That's actually just like turns. Okay, I definitely gave you guys one though. So if you please try to find it.
Wait, I don't think I put
Tutu
No,
for
I'm
bad.
talking, sorry, but you're just like not, okay,
Focus.
good. Okay, can you maybe like pull it back 10 feet, otherwise it's like weird. Alright,
So someone's bossy.
yeah, that's right. I'm trying to get some things done in a short period. Please read this question right now.
Rose's class seems a lot more fun than our period.
Can you please read this question right now?
Can I? Do you have an extra?
No. And this is a calculator problem, so it means that you should take out your calculator right now, and you will have to use your calculator to
Do we have to clear our memory for the AP?
Pretty sure I also gave you one. There will be a calculator section of the test. Half of the APM's calculator, you do need to know how to use your calculator.
Would you be? Could I borrow a calculator on that test?
Okay, no! Alright, can you guys just like tighten it up a little bit here, right? Get out your calculator. If you don't have a calculator, then you're just, I don't know what to say about you. That's like, you're unprepared for the class, okay? It's the magnet program, you're expected to have a calculator. Do you need a calculator now? Yes. Do you need a calculator on the test? Yes. If you don't have one, you're screwed, okay? So that's that. No, you can't borrow a calculator. That's that. Good. Great. Take out your calculator. If you don't have one, just suffer and please bring one later. If you don't own a calculator, go buy one. Alright. Good. Glad we got that out of the way. Alright, so these problems are not that hard, but there is a lot of reading comprehension involved. So what is going on? Can someone please summarize what is going on in this problem? Yes, Zach.
At 12 a.m. in the morning, there's no snow on her driveway,
Good.
and then snow basically falls
Yes.
all through the night until 9 a.m.
Yes.
at a rate of 7t times e to the cosine t.
Good. And notice that they're giving you a function which is like annoying and complicated and which you probably do not know how to anti-differentiate and like blah blah blah. Which is okay because they're just expecting you to do the whole problem on your calculator, right?
Yeah.
So this is your function, so pretty much immediately you should make sure your calculator is in radians and put this function into your calculator under y1. And then
Wait. Then,
what does this function actually represent, Zach? Tell me again.
Oh, the amount, like the volume of the snow that's...
Wait, careful.
The rate of change.
Yeah, the
This
rate
is
of
the
change as
rate.
the volume of the snow changes. That's what I meant.
Yeah, this is the rate at which snow falls. And we're assuming no like melting or anything. So this is going to be hopefully positive. Well, it's definitely going to be positive because it's e to the anything is positive and we're looking at t values on the interval 0, 9. So this is a positive function and it is the rate at which snow falls and the units are cubic feet per hour. Okay, and then what happens next?
At 6 a.m., then she starts shoveling her driveway at a rate of g of t. And g of t is a piecewise function that's given to us.
That is exactly correct. At 6 a.m. we start shoveling. And it appears as if she shovels at different rates. Okay, so g of t is the rate at which she shovels. Well, guess what? At time 0 to 6, her rate of shoveling is 0 because she's still sleeping, right? She doesn't start shoveling until 6 a.m. And then, suddenly at 6 a.m. she starts shoveling, and she basically shovels pretty hard for about an hour. She shovels at a rate of 125 cubic feet per minute. for the first hour, and then she continues shoveling until 9 a.m., but like less quickly. Now she only shovels 108. Has everyone got that? That's pretty clear from the problem, right? Okay, now we get to answer some questions. So here's a question. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? Colleen, what's the answer?
Oh.
0 to 9. Sorry. From midnight to 9, so.
Are you reading the question?
Oh, by 6. Oh, 0 to 6.
Yes. 0 to 6 of?
7 times t.
Yeah, of this function f. Done. Right? If we, can you enter that function into y1? If this is if f of t represents the rate, this is kind of like a follow-up to what we were just doing 2 minutes ago, right? If f is the rate at which snow is falling, then the integral from 0 to 6 of the rate at which snow falls represents the total amount of snow that has fallen. Follow? Okay, good. So make sure you enter your function into y1 correctly. Put out and just double check that you're in radians, otherwise everything is like garbage. Good. And now just take this integral. So math 9.
Wait, what do you do?
Zach, thank you. You want to do this? Really? How can you not know how to do this? We've done this like 10 times. Math 9, the function, which is y1.
How do you do y1?
Bars, y bars, function y1,
Oh crap, my theory. Never mind. Whoops.
What bars?
comma x,
Zach.
comma 0,
I don't know.
comma 6.
Look, my calculator does this.
Damn. Calculator does the entire thing for you. It's going to give you an answer. It's 142.275 by what's that word? Convention. The AP exam and hence me would like all answers reported to 3 decimal places, rounded to the nearest thousandth place. And what are the units?
Something per hour.
Cubic feet. No.
Oh
Units
wait,
are?
oh my bad. You're right.
Cubic feet of snow.
This is not the rate of change.
You have to put up snow.
Probably. I don't know. Cubic feet of something. Okay. Good. Next question. Find the rate of change of the volume of snow on the driveway. Yeah, question.
For the AP, do we have to indicate that we use the calculator or something?
No, they just know that there's no other way to do it. So it's like, yeah, they give you a calculator for the problem, and then they just know that you have to use a calculator. Okay, so good. Part B. What do we do now? Find the rate of change of the volume of snow on the driveway.
At 8 a.m.
Isn't
120.
You have to add those up.
125 minus whatever the rate of change is at f of t.
So it's the rate. Notice it's the rate. It's the rate of change of the volume of snow. Would anybody like to explain it to me?
F of 8.
Wait, isn't it f of
Yeah,
t minus
F, careful. F of 8 is the rate at which snow is falling. But they want to know the rate of change of the volume of snow. There's also some shoveling going on.
f of t minus
No,
t?
but at F of 8. Oh, at 8 there is shoveling going on.
Yes, at 8 there is shoveling going on.
Rate of it is being
So this is
added.
correct.
So yeah, so it's just the rate of change of snow is simply equal to the rate at which it falls
Oh, minus.
minus the rate at which it's being removed.
F of 8 like 2.
Yep, it's just that simple. It is f of 8, which represents, since f is the rate at which snow falls, f of 8 is the rate at which snow is falling at time t equals 8, minus g of 8, which is the rate at which snow is leaving. So, yeah.
But wait, h of t is supposed to represent the amount of snow removed.
G represents the amount of snow removed. G represents the rate at which snow is being removed.
Oh, no, never mind.
Okay, so what is f of a minus g of a? Again, you just use your calculator, but you are wasting your time retyping it, and you're gonna make errors eventually. So you should never do it that way. You should do it as just y1 of 8. Just vars vars function y1 of 8 minus 108. So the answer is negative 59.583, and the units are cubic feet per hour. So at time 8, what's happening to the amount of snow on the ground?
It's getting.
Yeah,
increasing.
she's shoveling faster than
It's
the
falling.
snow is falling, at least
Good
at that
job.
moment. Okay,
I know.
all right, part C. This part's a little bit more annoying. Let h of t represent the total amount of snow. Okay, so now they define a new function. They expect you to keep this all straight. Let h of t be amount of snow on ground. Amount of snow on ground.
Amount removed.
Oh, what is h of t?
It's the amount.
Oh crap, represent the total amount of snow that she has removed. Take it back. I didn't actually read the rest of the sentence.
Oh.
So, amount of snow Janet removed. Express h as a piecewise defined function with domain 0 to 9.
I have a guess.
Okay, Melchak.
So h of t equals like big bracket thing.
Yep,
0 less than or equal to t less than 6 is 0.
that is correct, because of course, she's removed no snow between midnight and 6 a.m.,
And
right?
then the next one is 6 less than or equal to t less than 7. The integral from 6 to x. Wait, what?
Oh, not
Okay,
yet. Wait.
okay,
6,
that's
6,
actually,
6?
that's actually correct. What she's saying that since the rate is 125, then it would just be, I actually like what you're saying. You're saying it's the integral from
6 to x.
6 to x of 125 like dt or something like that, right? Yeah, that is correct, because this is the rate at which the function is changing, and so this is like the point to which we go to. Or maybe I should, well, whatever. I guess I should make that t and that x.
Okay,
Because
Alex, this
the
is
variable
yours.
here is t. But this is, you can actually just do this, right? And what is this?
125.
This is 125, this is 125x evaluated at t and 6. In other words, it's 125t minus that number.
I was right.
You were right. 750.
Wait. Why is it 6 to 6 though? Why
Can't
isn't
you just
6
leave
to
it like
7?
that, though?
Yes,
6 to, isn't that what they said?
No, but it's a piecewise function, so
It's
it
a-
has to be working for like 0 up to 9.
I know, this is just a, that's of course.
Oh, I was so
Sorry,
confused for
sorry.
a second.
Yeah, so it's just, this is just gonna be, you could even just write it as 125, that's how they do it, t minus 6. Which you could probably just do even without calculus, right? I mean, if the rate at which she's shoveling, if she's shoveling at 125 cubic feet per hour, then depending on, if you plug in some number, like suppose it's like, 6 1/4 of hours, suppose it's like 6:15, right? That means 6.25, that means t is 6.25, you not pay attention. If it's like 6:15 a.m., that means it's like essentially time is 6.25, right? Which means if you take that number minus 6, that's the amount of time this represents the amount of time elapsed since 6 a.m. times the amount you shovel per hour. So that actually kind of makes sense. Okay, and then the next one is similar but a little bit different.
Oh,
I have a question.
108
Yes, Melchak.
times t minus
Why can't you leave it as the integral? Not like,
I wonder if they would accept that. They might just accept that.
because the integral like is a function.
That is,
Yeah,
that
they
is
might.
true.
They probably would just accept that. Yep. Yep. Okay, the next one here, what's this gonna
Is
be?
it 108 times T minus 7?
Yeah, but we have to be a little bit careful, right? Which is, in fact, maybe it's kind of worth actually writing like kind of what Melnichuk said, and then we'll maybe do like a final answer. Because what Melnichuk said basically is that for this time interval between 6 and 7, the amount of snow there is the amount of snow at the beginning of that time interval plus the net change in snow between 6 and t, and that is the rate. And then we concluded that since h of 6 is 0, because she shoveled no snow so far, right, at the beginning, then this is just that integral, and that integral is 125 t minus 6.
So we do h.
But now, maybe this is helping. But now, if I want to know how much
the way
total.
you wrote it is impossible. You have to change your less than or equal to if you wrote it like that.
Yeah, it's like a 6.
It's you have it
Yeah.
recursive.
Yeah.
Wait, that's kind of a
It
new
goes
class,
back to
but
the second page of 6.
Yeah.
It calls itself.
Sorry, I meant
so you
0.
just put 0.
I meant 0. Yes. How much snow? Is that what I meant?
No,
Yeah.
you just put 0 in total for the thing. You should know it's 0.
But
I think you meant in general
Yeah,
from
because
0 to
if you
6.
do 6,
of
it calls
0.
itself. Because you
Okay.
said equal to
So
6.
how about that? Better now?
But that's
But that's
No,
not what they
wait,
wrote
mister.
on the
Kind of, but
problem.
that's not
No,
what
but
they
I
really
think that
want.
is what I mean, right?
I think it's supposed to be the integral from 0 to 6 of 0, right? Because that's the amount accumulated between 0 and 6.
Isn't that always
It should be
0
the
though?
limit.
Yeah,
of
but
h equals 6.
That's the
Yeah,
idea.
yeah,
No, I think
Point-
this is what I mean. This is the rule for how much snow has she shoveled between time 0 and 6.
Yeah, but at 6 hours, like it's not like 6 hours and then she starts shoveling. Right at 6 hours, she starts shoveling
agree.
based
Yeah.
on G of T. So what you've written is kind of wrong.
Why is it wrong?
think.
Why is it wrong?
Because you can't put less than or equal to for the 6 because in the original problem, it states it writes it in a way that exactly
Oh my
at
god.
6 hours.
Okay,
she
I don't know what to
starts.
say. Alright.
You're off by like 0.0001 second.
Okay, moving on. How much snow has fallen? How much total snow has she shoveled? For some t value between 7 and 9.
So do you have to do the thing where it's like h of 7?
Exactly. So
Plus.
the answer is it's the amount of snow that she shoveled up to that point, which is h of 7, plus the amount of snow she shovels from time 7 to some time t. And now she's shoveling at a rate of 108.
That means you have to do the
And what is h of 7?
equal to 7 also.
What is h of 7?
The
108.
125 thingy. The
Or
integral
125, sorry.
from.
It's 125, right? Because if she's shoveling at 125 cubic feet per hour and she shovels from 6 to 7 for 1 hour, then by the time we get to 7 a.m.